Today what we'll be doing is looking at and applying our knowledge of gradient and our knowledge of rule finding together to write some equations in gradient intercept form. All right, so as usual, what I like to do is just look at stuff that we've done earlier and try to kind of see if I can show you what the application of that will be for today. So for the table of values above, find the rule. Okay, so remember what we did was a four-step process. Step one involved you looking at the table of values and finding somewhere within the table of values where you can get the x values to increase by 1. So we can see that there's an option. This would also be an option here and here. So just it's easiest to go from 0 to 1 probably. And we can see that as x increases by 1, we can see that the y values go down by 1. So 1 to 0. So it goes down by 1. And we note this value for step 1. Step 2 then was to find the value of y when x is 0. And here it is here. So when x is 0, y is 1. And we note that value down. Now step 3 involved us writing our equation, where what we did was put the answer to step 1 there and put the answer to step 2 there. So we're going to officially write our equation as y equals negative x plus 1. Now remember, step 4 was test it. So what we'll do is use this point here. So I'm going to substitute x equals 2 in, and what it should do, if it's working correctly, is the rule should produce negative 1. So let's try it. Y equals negative 2 plus 1, and indeed that equals negative 1. So our rule is working. Okay, so this rule, or the rule that we've just found, is said to be in gradient intercept form. Okay, so here is gradient intercept form. And this value here, m, that's what we call the gradient. Right, so this thing that we did here was when x increases by 1, we looked at the change in y values. Remember, that's just the gradient, and that's what we've used as a name for that particular thing. Now c, this c value here, all that is the y-intercept. Okay, the y-intercept. And what is the y-intercept? Well, if we imagine a graph, okay, and a linear equation on the graph, then the y-intercept is where it goes through the x-axis at this point right here. Okay, and we can see that that's when x is equal to 0. So we're looking for the value of y when x is 0. The value of y when x is 0. So what we're basically doing in step 2 is we're finding out what the y-intercept is. So just as a reminder, we've looked at these ways to calculate the gradient and slope of the line, and there really is no one best method. It's just what's easiest for the scenario. So we look for the change in y values as the x values increase by 1, or we calculate it by doing change in y over change in x. We can use the rule, y2 take away y1, which is the change in y, over x2 take away x1, or we can calculate it from the graph using the rise over the run. So today we will explore more ways to find the y-intercept. Okay, so what is the gradient and y-intercept for the graphs of these rules? So again, we're not going to actually draw the graph or visualize the graph. All we're going to do is we're going to compare that to y equals mx plus c form. Now we can see that the value of m is this one here. This is the 3. So we're going to say m equals 3. And this c value here matches up with this value here. So c is equal to 1. Now remember what our notes say. So m is the gradient and c is the y-intercept. So we can say the gradient is 3 and the y-int is 1. And we can write that y-intercept as coordinates or an ordered pair, because the y-intercept occurs when x is equal to 0. So when x is equal to 0, the y value is 1. That is the y-intercept. Okay, this one is a little trickier. Okay, so what we're going to do is just rewrite this equation as a fifth times x take away 3. Now again, let's compare that to y equals m times x plus c. So we can see that the value of m is this value here. and the gradient is allowed to be a fraction. Okay, so that's perfectly allowed. So we can see there that the gradient is 1/5 and y int is this value here, the plus c, that's going to be take away 3. As a coordinate, when x is 0, y is -3. Okay. Now what we're going to do is the same thing, but we're going to find the rule for these graphs by first finding the values of m and the y-intercept. Basically, what we want to do is just find the rule. Okay. So we're going to write the rule in y equals mx plus c form. That means we need to find the gradient and the y-intercept. Well, I can see the y-intercept over here. This is the y-int. So we can see that it's where the line goes through the y-axis. When x is 0, y is -1. All right, now how can we get the gradient? So there's all sorts of ways, but I'm just going to put this quickly into a table of values. 0, -1, and 1, 3. Now it's really convenient that I can see as x increases by 1, the y values go up by 4. So I know that the gradient, m, that's got to be 4. Now the y-intercept, I can see is c equals -1. So I can see that that is going to be where it goes through the y-axis. So let's write our rule. Y equals 4x, take away 1. All right. So the last thing we should do is probably test it just on a point here. So we're going to put this 1, 3 in here and see what happens. So this is an ordered pair when y is equal to 3, x is 1, 4 times 1, take away 1. 3 equals 4 lots of 1, which is 4. 4 take away 1 is 3. Okay, so my rule is working. So find the rule for the graphs by first finding the values of m, i.e. we've found the gradient, and then we've found the y-intercept. So we've got all of what we require there. Okay, let's do this one here. So again, you should note that it slopes downwards. So that means that our gradient should be negative. All right. So let's use a different method this time. We'll use the rise over the run. So starting at this point here to find the gradient, I'm going to scoot across and then down. Now I can see there that the distance of this line here starts at 1 and then goes to 2, so that's 1. Now we can see the fall here is going to be from 2 down to 0. So this is going to be -2. So the gradient, m, is the rise, which is -2, over the run, which is 1. So m is -2. All right, the y-intercept. Well, we can see here that it looks to be 4, 0, 0, 4. So when x is 0, y is 4. But let's just try it with a table of values and see whether that matches up with what we think will happen. So x, y. So I'm going to put in 1, 2, and I'm going to put in 2, 0. Now recall that what we're looking for the table of values for the y-intercept is 0. So I'm just going to continue the pattern. So that's going to be a 0 there, and this needs to be a 4. So it goes 4, 2, 0. So absolutely our C value there is going to be 4. So now we finish this by writing the rule, or what we think is the rule, which is y equals this value here, -2x, and the C value plus 4. All right, so that's considered being written in y equals mx plus c form, where m is -2 and c is 4. The final thing we should do is just test it. So I'm going to test it on this ordered pair here, x, y. So 0 equals -2 times this x value here, which is 2 plus 4. 0 equals -4 plus 4. 0 equals 0. That's true. That means my rule works. Okay, the last two examples. So this one here, okay, what we should note is that this line here has got a 0 gradient, okay? So we've got a 0 gradient. Okay, because as the x values go up, the y values don't change. In fact, the y values are all the same. -2, the y value is -3. Here, the value for x is 4, the y value is -3. What's the y value? The y value is always -3. How do we write that as a rule? Y is always -3. Y is -3. And that's our rule. Because no matter what x value you give the rule, this says back to you, y is always -3. So that's how we find the rule for a horizontal line. Now here's our vertical line, and what we note is that the x value here, no matter what y value we look at, if we look at this value here, 2, the x value is always 3. That's 3 comma 2. So notice that the x value is 3. This is the x-intercept, 3 comma 0. Let's try another one. This one here, when x is 3, so the x value is 3 here, the y value is -4. So notice that the x value is always 3. So that's how we write our rule. X is 3, and that's our rule. Okay, and remember the gradient for this one here, we say that the gradient doesn't make sense. Our definition of gradient that we've been using is as x increases by 1, what's the change in y values? The problem here is that x does not increase, so the gradient doesn't make sense. So we say that there is no gradient. All right, so from here, what you're going to do is exercise 9E, all of those questions. So that's 1A, 1B, 1C, etc., etc. So good luck, and I'll catch you later in the week.